Dear students, welcome back. Today we'll discuss the RSA algorithm, which is the public key cryptographic algorithm. Before we proceed with the RSA algorithm, let us understand the different types of cryptography and the general model of the cryptography. So, what is an encryption and decryption? So encryption is nothing but the process of converting the original message, which we call it as a plain text, in order to convert into some unreadable format called ciphertext. The process of converting plain text into ciphertext is called as what? Encryption. And decryption is the reverse process of encryption, that is conversion of ciphertext into the original message or plain text, that is called as what? Decryption. Encryption happens at sender side and decryption happens at sender side. So here we have sender and receiver. So the input to the encryption algorithm is message or the plain text. So one more input to the encryption algorithm is we need to have a key. We need to operate key with a message so that we will get ciphertext C. So again, what is the input to the decryption algorithm? Input to the decryption algorithm is ciphertext and some key. So you will get the original message M back, which is nothing but a plain text. So here we can have different types of ciphers. What is meant by a cipher? Cipher is nothing but the algorithm used for an encryption or decryption is called as what? Cipher. So if we add message plus key, it is called as what? Additive cipher. If you multiply message with a key, it becomes multiplicative cipher. If you have a message, if you operate key on the exponential, for example, m raised to e, that is called as what? Exponential cipher. Different types of operations can be performed over here. And when it comes to different types of cryptography, we have first one, symmetric key or private key or single key cryptography. As the name indicates, in single key cryptography, both sender and receiver will be using the same key for encryption as well as for decryption. See here, sender wants to encrypt the message, input is message M and operate with some key K, you will get ciphertext C. So input to the decryption algorithm is ciphertext, and here receiver will also apply the same key which is used for encryption. So in order to convert ciphertext into plain message M back. So here both sender and receiver will be using the same key. So therefore the name single key or private key or symmetric key cryptography. The other type which we have is asymmetric key or public key or two key cryptography. Okay. So in a public key cryptography, if sender wants to send message to the receiver, then sender has to encrypt the message using receiver's public key. Okay. Here public key is known available to public and private key is kept secret with the receiver. So sender A wants to send a message to receiver B. So the input to the encryption algorithm is message M and we need to use receiver's public key. So therefore we have written PU of B. Okay. So the resultant is ciphertext C. So this happens at the sender side and at the receiver side. Now the message is for receiver B. He has to decrypt and read the message. In order to do so, so we will be using the receiver's private key because the receiver's private key is known only to that particular receiver. So here we will be operating PR of B in order to get the same message M back. So the name is two key cryptography or public key cryptography or asymmetric key cryptography. Public key is used for encryption and private key is used for decryption. So RSA follows public key cryptographic approach. Now coming to the RSA algorithm. So it is developed in the year 1977 by Ron Rivest Adi Shamir, and Len Alderman. So therefore, the name, the Rivest Shamir Alderman RSA. This scheme is mostly widely accepted and implemented general purpose approach to public key encryption. The RSA scheme is block cipher. So in the previous slide, I told you about the cipher. Basically, cipher is nothing but any algorithm is used for encryption or decryption. If I encrypt single byte by byte or character by character or single uh, number by number, it forms what stream cipher. We are going to take a stream of text from the input and we are encrypting it separately. Say for example, a letter hi, I'll encrypt h once and I separately. This becomes a stream cipher. What is meant by block cipher? Say for example, hi, hello, how are you? At the time, if I group that letters, okay, into some blocks. Say for example, here assume that block size is 2. Hi. After that, for hello, I'll take next 2 characters, he, next ll, next oh, something like that. So we are going to encrypt the entire block. That is called as what? Block cipher. Here, plain text and ciphertext are integers between 0 and n minus 1 for some value of n. The size for n, here n is nothing but the modulus value. So usually it will be having 1024 bits or 309 decimal digits. N is nothing but the modulus value. So plain text or message BM, ciphertext CT, or you can simply denote it as C. There are 3 steps to implement RSA algorithm. First, obviously, we need to generate the key generation. For that, we need to generate public key for performing encryption, and we need to generate private key in order to perform decryption. So once you have a pair of keys, that is public key and private key, then you go for encryption, then decryption. Let us go through the algorithm. This is the algorithm. So plain text and ciphertext are integers between 0 and n minus 1 for some value of n. Public key, as I discussed, it is known to all users in the network. Private key is kept secret, not shared to all. Okay. First part is key generation. For the key generation, we are going to select 2 large prime numbers, say P and Q. Roughly, it is 256-bit prime numbers. Okay. Next, calculate the modulus value, which is nothing but n, the product of 2 primes, that is n is equals to P into Q. Next, calculate phi of n. Phi of n is nothing but Euler's torsion function, which is equal to P minus 1 into Q minus 1. That is Euler's torsion function. Then choose the value of encryption key E in such a way that E should be greater than 1 and E should be less than phi of n. So the most important condition for choosing the value of E, that is integer E, so GCD of Euler's torsion function, that is phi of n comma E equal to 1. This is most important in an RSA algorithm whenever you choose or select an integer E. Okay. Next, you need to calculate D for decryption. So D is congruent to, this is nothing but the congruence symbol. D is congruent to E inverse mod phi of n. E inverse can be written as 1 by E. If I take that E on the other side, E into D congruent to 1 mod phi of n, which can be further simplified as E into D mod phi of n equal to 1. Here we have eliminated the congruence sign. So therefore, how to calculate the value of D, which is nothing but E into D mod phi of n is equal to 1. So once you have an integer E and D, then you generate the public key, which is nothing but public key PU equal to E comma n, which can be used for encryption. E is an integer E, which is nothing but for encryption key with respect to modulus value n. Okay, that will be used for decryption. For private key, so we'll be using D with respect to modulus value N, that is used for decryption. So the first part is key generation. In order to generate the public key and private key, this is the procedure. Okay, so how do you choose E? Condition is GCD of phi of n comma E should be equal to 1. How you calculate D? So the formula is E into D mod phi of n is equal to 1. Once you have public key and private key with you, next is you need to encrypt the message. Message is M. So here the input to the encryption algorithm is message M and key. Which key we are using? We are using public key for encryption. So message M raised to E mod N. We are performing exponential cipher operation over here. So M raised to E mod N. Once you do this, the resultant will be ciphertext C. Okay, this is for encryption. How about the decryption? The input to the decryption algorithm is ciphertext C. Then we need to operate it with the key. Okay. In this example, and the receiver will decrypt the message using his own private key. So therefore, we need to use private key, which is nothing but D comma N. So C raised to D mod N, which is equal to the message M or the plain text. This is the algorithm for RSA. So key generation is the first step. Next is encryption, and the third one is decryption. So let us solve this algorithm by taking a couple of examples.